will flow through what actually? Which will flow? Solvent through what actually? What? Semi-permeable membrane, but not the solute. Then how it will flow? Both are what? Solutions only. Here it is solution, and here also it is. Both are what actually? Solutions only. Both are what? Solutions only. But solvent is moving from 1 to 2 or 2 to 1. That depend upon what? This condition. Solvent will flow from a dilute solution to concentrated solution. For example, here I have taken salt solution having 0.1 molar salt solution I have taken. Here I have taken 0.01 molar of, isn't it, concentrated solution. This is the concentration. Both are same solutions only, but difference is what actually here? Their concentration. Now, which is lower concentration beta? 0.1 or 0.01? Which one is lower concentration? Nishant? Which is the lower concentration beta? 0.01. Nishant is not there. This is the lower concentration. Absent. Okay. Nishant is absent today. Right. High concentration. So definitely solvent molecules are flowing from where? 2 to 1, but not 1 to 2. Solvent is flowing from where? Here like this, 2 to 1 like this. It is moving like this. Like this it is moving. So this observation we are calling as simply osmosis. So what is osmosis? Simple definition. When two concentrations of solutions are separated by semi-permeable membrane, then the flow of solvent flows from lower concentration to higher concentration is called what? Osmosis. Is called what? Osmosis. Simple or not? The flow of solvent from dilute solution to concentration solution, when these two solutions are separated by a semi-permeable membrane. So this process you are calling as osmosis. Anybody having doubts regarding osmosis?
No, sir.
Right. Next, we will see the phenomena in this one. So I have taken what? A funnel, a distal funnel to whose mouth a semi-permeable membrane is used as is shown in the figure. For example, you take this one. To explain the phenomena of osmosis, I have taken water only. Here I have taken only water. Okay, here it is taken water. Now this is a permanent semi-permeable membrane here. Here it is. This is the permanent semi-permeable membrane. Now this one is a dilute sugar solution. This is what dilute sugar solution. It is a dilute sugar solution. Whichever you taken in the funnel, in this funnel, you are having what? Solution. A dilute solution. You are having a solution bed. Outside of this funnel, what you are having? Solvent. Understood? Outside of this funnel, you are having solvent. Inside of the funnel, you are having what beta? Solution you are having. Outside solvent, water. Inside of the funnel, solution you are having. And this funnel at the bottom here is coated with what? Semi-permeable membrane. Now, when you put this funnel in the water, because of this semi-permeable membrane, natural process called osmosis will take place. Now tell me, solvent will move from where? Solvent will move from where? Solvent, Dhruv. Solvent will move from where? Dhruv. Dhruv is absent today. Whoever not responding, I will put absent. That's it. Because today,
yes, sir.
We are starting revision also. Dhruv, absent.
So he is not there.
Dhruv is also not there. Only Vinayak is there. Remaining are absent. Nidhi? Nidhi?
Yes, sir.
Bolo beta. After keeping like this, now osmosis takes place from where? Where to where it is taking place? Dilute to solvent or solvent to dilute solution? Tell me beta, according to this concept, you have to tell me. According to this concept, tell me now that. Too fast. If you don't know, tell me no. That's it. I want response. Yes or no. So that you are listening. What happened?
Sir,
Here,
dilute.
here to here or here to here like that? The flow from red to blue or blue to red? Tell me better now.
Blue to red.
Blue to red. Why? Because see, solvent does not have any concentration. Just take as a low concentration. At least compared to this solvent, this is what more concentrated or not. The solution is more concentrated when you compare with what solvent. Correct or not? Pure solvent concentration always, isn't it, lesser than the solute concentration. Remember this concept. Pure solvent concentration always lesser than the concentration of the solution. Based on that, what happened? Definitely solvent water will move towards what? Sugar solution. Now water is moving toward sugar solution. Understood? Always natural phenomena, this one spontaneous phenomena in which whenever two solutions are separated through a semi-permeable membrane, solvent but not solute, solvent will move from lower concentration to higher concentration, otherwise solvent to solution side. Otherwise what happens? Solvent to here. This is solvent. Solvent to what? Solution side. Two things you have to remember. Low to high concentration, otherwise solvent to what? Solution side actually. This is the way of what? Osmosis, right? Next. In this case, what you are observing, the liquid level in the stem rises slowly with the time. After certain interval of time, the level remains constant because an equilibrium established. Now, what is happening here? For example, if you take only up to here, you are taking the sugar solution. You are taken only up to here. This much only you have taken before the starting experiment. This much only you have taken. But after certain time, the rise of this one will increases here, and the solvent will, when the solvent is moving in this one, the solution will rise up to here. Indicating what actually, after certain time, what happened? Indicating what actually the solvent is moving towards what happened? Sugar solution. But at certain time, this will stops because when these two having what same concentration. Because once this solvent is getting into this one, what happened? Both will get same concentration and equilibrium will be established. Further osmosis could not take place. So the increasing the everything is what happened? The flow of solvent molecules into sugar solution. You are calling this one as what? Osmosis. This is the osmosis process. Right? So this you have to read about. Next we'll see the explain करने की जरूरत नहीं. Just now let me take here what happened now. Next thing is what? This is important for us. The pressure required to be applied on the solution side. So I'm applying some pressure better. I'm applying some pressure on this side, solution side. That means here on this side I'm applying some pressure here. I'm applying some pressure from which side? Solution side. On the side of what? Solution side. In order to, isn't it, stop the flow of solvent into the solution. I want to stop this flow from here. Now I want to stop the solvent entering into the solution through what? Semi-permeable membrane. Now how much pressure I am applying? Okay. In order to stop this flow is called what? Osmotic pressure. What is osmotic pressure beta? The pressure required to be applied on the solution side to stop the inflow of solvent into the solution. When the solution is separated by the semi-permeable membrane, it's called osmotic pressure. Right? So I have taken again one more, again same example I have taken. Semi-permeable membrane is there. This is semi-permeable membrane. Here solution 1 is there, here solution 2 is there. Solution 1, solution 2. Now this is having what? 0.1 concentration, this is having 0.01 concentration. Now definitely what happens? Solvent will move like this. Solvent is moving like this. 2 to 1 is taking place. Now applying some certain pressure, which side here? Solution side. For example, if it is solvent, okay. If it is solution, I am applying this side actually. On solution side, I am applying actually. Okay. Otherwise, you take this one, 0, 1. This one is 0.1. Otherwise, you take this, for our understanding, what happened? You take, this is solvent, and this one is a solution. Okay. Now, we are applying on pressure on the solution side. in order to prevent the osmosis. So very simple, the pressure which is applied on the solution side in order to prevent the osmosis. To prevent the osmosis, what pressure we are applying? That pressure is called what? Osmotic pressure. I think everyone understood this one. Definition, osmotic pressure in examination is important. 1 mark question. So what you write in that one, the pressure which is applied to prevent the osmosis is called what? Osmotic pressure. This is a very beautiful example, beta. This is a semi-permeable membrane. This is a semi-permeable membrane. This is sugar solution. This is solvent solution. Now, where we have to apply the pressure? Sugar solution or solvent side? Where we have to apply, beta? On sugar solution or solvent side?
Sugar solution.
On sugar solution, you are applying something pressure here. Applying by using a piston. Okay, where you are applying, beta? On solution side, you are applying it. See, you are applying some pressure on the solution side. So now what happened? The phenomena of osmosis will be what? Stopped here. So excess pressure equal to the osmotic pressure must be applied on the solution side to prevent the osmosis. Here some pressure will be there. Here some pressure will be there. But where you are applying excess pressure, beta, here you are applying the pressure. Because it's an experiment, both are having some pistons are there, okay, but where you are applying the pressure, here also. Already some pressure will be there. The pressure we are calling atmosphere pressure. This is already pressure. But this pi you are applying, this pi is nothing but called, beta, osmotic pressure can be represented by pi. Osmotic pressure can be represented by which letter, beta? Pi. Which symbol? Pi actually. Right. Just now we discussed everything. 2 parts we fitted with pistons, and the piston on the solution side moves due to osmosis. The pressure is applied on the solution, which is numerically equal to the osmotic pressure. The momentum of the piston can be stopped. Pressure applied on the solution side to stop the process of osmosis, numerically equal to osmotic pressure. Now formula will be what? What should be the formula for the osmotic pressure? Now, already you know this one ideal gas equation. Everyone knows the ideal gas equation. PV is equal to NR. Now, why I have to take this equation, beta? Why I have to take this equation? See, we are discussing about ideal solutions. Ideal solutions only we are discussing. Correct or not? Next thing is what? We are discussing for dilute solutions. Because colligative properties are exhibited by only dilute solutions, but not the concentrated solutions. Correct? Now, so which formula we are taking? PV is equal to N1. Now, put this in the place of P. Put what? Pi actually. Because pressure for P for gas mole. Pressure for the P for what? Pressure for the gas. Pi for what? Pressure for the solutions, liquids. Now, pi V is equal to nRT beta. The formula becomes here pi V is equal to nRT. Now, put this V over here. N by V is equal to N naught. Anybody know what is the meaning of N by V? Anybody knows what is the meaning of N by V?
Molarity.
Molarity. N by V is equal to molarity beta. अभी join हुआ. N by V is equal to what? Concentration, nothing but molarity. Molarity is nothing but what, beta? Concentration only. No. What is the meaning of molarity? Concentration. Number of moles of solute dissolved in the solution is nothing but concentration. Now, shall I place in the place of N by V? N is equal to number of moles. V is equal to volume of the solution in liter here. Okay. Now, pi is equal to what we can write? CRT we can write. Now, R generally we use for as a gas constant beta. R is nothing but gas constant whose value will be 0.0821 atmosphere, 0.0831 bar, otherwise 8.314 joules, otherwise what happened 2 calories. That is for gas constant. But because it is a solution, no, in the case of solution, put in the place of R, CST. Okay. Yes for what? R for gas constant. Yes for what? Liquid constancy. Understood better? So what is the formula? Pi V is equal to NST or pi is equal to CST are very good formulas useful examination point of view. Next, what is the use of this osmotic pressure? So very important point better this. Generally student will neglect this point. Very important point. What is this? Osmotic pressure is useful to determine the molar mass of the substance, especially for the polymers. Especially for the polymers, what is the molar mass, molecular weight of given solute? So we are calculating the molecular weight of solute. We are calculating. Useful in the MCQs beta. Important, isn't it? Application of osmotic pressure is what this one. Osmotic pressure is widely used in the determining molar mass of especially polymers. Polymers are nothing but what? Proteins, macromolecules, polymers, everything what happen which are having large molar mass, which are having what? Very large molar mass. Whichever having large molar mass, whose molecular weight, molar mass can be calculated by using osmotic pressure. And this is the osmotic pressure method has advantage over the methods as it is generally carried out at room temperature. When you compare with what happened, remaining methods like depression freezing point, elevation of boiling point, lowering of vapor pressure, we have calculated molecular weight. If you observe the last class, we calculated the molecular weight by using what? Relative lowering of vapor pressure. Elevation of boiling point, we calculate the molecular weight. But that methods are not very good methods because they may carry out any temperature, different temperatures. But here, osmotic pressure generally at room temperature we can carry it out. Therefore, is a very good method for calculation of what? Molar. Osmotic pressure magnitude even is a very large dilute solution. Even you take very large dilute solution also, it will give the values. Two solutions having same osmotic pressure at a given temperature called isotonic solutions. This is very important for one mark question. Many number of times you got this question. What are isotonic solutions? Question is what? What are isotonic solutions? Very simple. Two solutions are there in which pi 1 is equal to pi 2. Whenever pi 1 is equal to pi 2, then the solutions are called what? Isotonic solution. I have taken two solutions here. And these two solution 1, solution 2 are having what? Same osmotic pressure. Pi 1 equal to pi 2. Then they are called what? Isotonic solutions. Correct? Right. No osmosis takes, cannot tell me better. Now osmosis takes place in isotonic solutions. Yes, beta? Osmosis takes place.
No.
No. Why? Because osmosis can be prevented by applying what? Osmotic pressure. By applying osmotic pressure, we can prevent what? Osmosis. And both are having same osmotic pressures. Both solutions are having same osmotic pressure. Then osmosis never takes place here. So, no osmosis takes place between isotonic solutions. For example, blood. All of you please listen better. Examples are very, very important for examination point of view. Very important. Blood and 0.9% WB by NaCl solution. What is the meaning of 0.9% W by V? 0.9% of W by V. Vaishnavi?
0.9 grams present in 100 ml.
0.9 grams present in 100 ml of solution. 100 ml of solution, 0.9 grams in 100 ml of solution, because V is solvent, solution. V is solution better. Here I have to take it. Where weight is solute, here I have to take it. Now, blood and 0.9% of NaCl solution is always isotonic solution. Now tell me, between blood and, I am taking here, between blood, this is blood. And this one is 0.9% NaCl solution, which is separated by semi-permeable membrane. Tell me better now, osmosis takes place or not? Vaishnavi?
No, sir.
Definitely what happened? Osmosis does not take place. Why? Because both are isotonic solutions. Don't take 1% here. If you take 1% of NaCl, what happened? They are not isotonic solutions. Now, the solvent never moves to blood to salt or salt to blood. Now, whenever if you take what happened, glucose, okay? For example, if you are severely what happened with dehydrated, you are dehydrated. So what happened? Doctor definitely prefer you a glucose. So you have to take the glucose. In that case, the percentage, if you observe in that, 0.9% will be there. 0.9% of NaCl generally they will allot you. Why? Because if you take the glucose, what happened? This osmosis should not be takes place. So that what happened? The solvent present in the blood, nothing but water only, cannot go into the salt, or water present in this one also could not take place. So blood is isotonic with normal saline water. Normal saline water. Saline water contains what? 0.9% of WB by NaCl solution. Understood better? Right. The very important one, remember this one. Blood and saline water, that is nothing but 0.9% of NaCl solution or isotonic solutions. Now, these remaining topics also very important biological actions are there. Let me take first of all, hypertonic solution. Hypertonic solution or plasmolysis. I think you know this one because of the biology students. You know more than me because of this is the biological concept. Hypertonic solution, plasmolysis. Let me discuss about. Again, I have taken what? 0.9% of W by V sodium chloride. Saline water I have taken. Okay. Now, what I am doing here, if you place this, a cell placed in this solution. I have taken a cell beta. We are taking a cell like this. Just imagine this is a cell, right? This is a cell actually. Where I am placing here this cell? I am placing in the 0.9% of NaCl solution. I am placing over here. Then water flows out of the cell and it shrinks. So now what is happening, beta? When you place, isn't it, a cell, we are placing a solution which is having more than 0.9%. First we will take more than, then we will take is equal, then we get less than also. First of all, we take greater than 0.9% sodium chloride. That means it may be what happened. I am taking how much? I am taking 1% of NaCl. 1% of NaCl solution I have taken. I am placing the cell, a blood cell. Just imagine a blood cell. Blood I am placing. A cell of blood I am placing something like this. Like this I am placing. Now tell me, beta, blood contains how much, beta? 0.9%. The cell contains how much percentage concentration? 0.9%. Correct or not? Now, the solvent will move from cell to what? Salt. Correct or not, beta? Is it correct or not? When you place a blood cell, a cell in the water, in the salt solution that having 1% of NaCl, the flow of solvent will flow from cell to salt or salt to cell, beta. Tell me fast.
Cell to salt.
Now, whatever the water contained in this cell, whatever the water containing in this cell going into where? Salt solution. Always from low to what here? High. Low to what here? High. Correct or not? So, because of this, cell gets shrink. Cell get the shrink, dry. It become dry. Simple thing I am saying, it become dry. Cell become dry. Shrink. It will shrink like that. It will shrink like that. Like that it will shrink. Something like small size. Shrink it. Such solutions you are calling as, when you put what happened, isn't it? Whenever a cell in a sodium chloride solution having more than 0.9%, that type of solutions are called hypertonic solutions, and the process called what? Plasmolysis. Next we will see the reverse process now. Reverse. The same cell you are placing, less than 0.9%. Less than 0.9%, again the same cell I am taking it. The same cell I am taking it. Okay. Now the solution concentration, if you observe, that is having 0.8%. Okay. Now this blood cell is having how much, better? 0.9%. Now definitely the water, the solvent is nothing but your water will flow from salt to cell or cell to salt, better?
Salt to cell.
Now water will flow into the cell now. Water will flow into cell like this. Water will flow into the cell. Because of this, what happened? Huge amount of water will be there inside the cell. Now the cell will be swell. Cell will be expanded here. Swelling takes place here. Swelling of the cell will take place. Such solutions are called hypotonic solutions. Such solutions are called hypotonic solutions, also called hemolysis, we can call. So, if I place what happened? Again, a blood cell I have taken and putting water. water is having 0.9% and the cell is also having 0.9%. Now what happens? Solvent will move from there. Nothing. It is isotonic solution. So if I take more concentrated salt solution, the process is called what? Hypertonic. If I take lower concentration when you compare with blood, that is called hypotonic something. Lower. Hypo means nothing but better. Lower. Correct or not? Hypo is nothing but lower. Hyper is nothing but what? Higher. Correct or not? In that way, you can easily remember plasmosis and hemolysis. Now we take one more application. Plants takes up the water. Plants takes up the water from the soil through what? Roots. Correct or not? Generally, if I take a plant here, these plants will take the water from the where? From the earth. That means from the root, through the root, from the earth, it will take the water. This is also exhibit what? Osmosis only. Why? Because you observe one thing. So why? What is taking place to the whatever the plants like this? Something whatever the water is there underneath of this tree, that water is going towards the tree to the root into the plants. This is also what osmosis process. Because here less concentration, in the tree what happened? More concentration. So water is flowing like that. This is having less concentration water. And in the tree what happened? More concentration. So it will move from what? Soil to what? Tree actually. A person involved in an accident when admitted in hospital is administered some saline. Why? What is the reason? Anybody? A person involved in the accident when admitted in hospital is administered a normal saline water. Why? Because a person involved in the accident loses a lot of blood. As a result, osmotic pressure will fall. Isn't it? When you're losing the lot of blood, what happened? Osmotic pressure is falling. To maintain the osmotic pressure of the blood, the person is administered saline, as saline is isotonic with blood here. This is the reason actually. What happens to raw mango when it is placed in the concentrated salt solution? So have you prepared pickle beta in your home? Anybody have prepared the pickle? Mango pickle? Anybody?
Yes, sir.
Mango pickle, do you know that one? Right. Now let me take an example of mango pickle. So you have prepared mango pickle, okay? So in that case, what we'll do? Mango, isn't it? Is dissolved in the salts like that. Salt, isn't it? Spicy items here, salts, isn't it? Salt and everything. The spicy items, into that you are dissolving this mango pickles. Mango actually, right? The pieces of the mango, small pieces of the mango, we are dissolving there in the salts. Okay, salt, everything here. Whatever you are having, spicy items, everything. At that day, the mango is not having taste. Nothing taste it will be there. But after 1 week, when you dissolve this mango small pieces in the salts, spicy items, this mango gets some taste. Why? Because see, whatever the water present in the mango, whatever the water which is present in the mango will move from mango to salts, because salts will have what? More concentration. Correct or not? Because whatever the salts we are adding, spicy items we are adding, they are having more concentration. Whereas the mango is having what? Less concentration. The pieces of mango, if you observe, they're having less concentration. So when you put up to 1 week, what happens here? Whatever the water present in the mango will now move into the salt solution. Now mango becomes what happened here? Dry. Mango becomes dry, and that will be very tasty for us. So in the pickle, making of the pickle, what happens? The solvent present in the mango, the water present in the mango will come outside here. So this will happen here. It loses water via osmosis and converts into pickle here. Correct or not? What happens to the raw mango when it is placed in the concentrated salt solution? Which process is taking place? Beta? Osmosis. So process of what? Pickle is nothing but called osmosis only. Next. What happens to the wilted flowers when placed in a fresh water here? Okay, because of the osmosis, a carrot which has become limp when placed in open atmosphere can be revived or become film by intake of water through the osmosis. Again, water will flow into the flower, so that water will get brighter. It will get bright. Vegetables vendors often keep sprinkling of water on the vegetables to keep them from film, isn't fresh. To keep them fresh, what happened? They will sprinkle the water. Same thing it is. Vegetables exposed to the air, they lose their water from the cells, isn't it? Because of what? Osmosis. Hence, when water is sprinkled on them and take water through the osmosis. Okay. People take lot of salty food, experience water retention in the tissue cells, and intercellular space becomes osmosis. The resulting puffiness swelling is called edema. For example, you went to some function. You went to some function. There you eat, what happened? You ate something. What happened? Huge amount of salt items here. Some biryani you ate actually there. Salty biryani you ate. So after half an hour, what happened? You will get thirsty. You want more amount of water. Why? Because of what? Huge concentration of that salty food items. Whatever the water present in the tissues will go out actually. So you need some water in that case. Okay. So whenever if you eat salty type of things, what happened? Whatever the water present in the tissues, intracellular, they lose water actually. So you are getting thirsty. You want to take more amount of water in that time. Now, meat is preserved by adding salt, which prevents the bacterial action, because when you place the meat in salt, whatever the water contains in the meat will go outside here. The water contained in the meat will go outside. Meat becomes dry. So when it becomes dry, what happens? You can preserve that one for long time. If it is dry, you can preserve for long time. If it is wet condition, having water, that will be easily damaged. Fruits can be preserved in sugar solution to prevent the bacterial action. So that what happened? You just removing the fruit, excess amount of fruit present in that one by using salt solutions like that, sugar solutions or like that. These are all actual examples here. Through this process, what happened? Fruit loses the water here. To the osmosis process, fruit loses the water. All are examples here. Now let me discuss the problems now, because in examination, too much applications we discussed here in the point of MCQs. Now let me take what happened, questions now. Now this is a molar elevation constant is depend upon, this is actually, I had already told you, molar elevation constant definitely depend upon the solvent. Why? Because last class I will explain this one, what actually molar elevation constant we got from where? 1000 by something molar mass, no, something, so molar mass by 1000 something we got, no, molecular weight of the solute, depend upon the molecular here, so it will definitely depends actually. Tell me better now, one question you have to observe here. In which of the following solution of same molality you expect higher elevation of boiling point? It's not related to osmotic pressure, we'll do that problem, but do you have any idea about this one? Which will have more elevation of boiling point? Now tell me better, elevation of boiling point, delta TB is directly proportional to molality, correct or not? Elevation of boiling point is directly proportional to what? Number of moles of solute particles, correct or not? Number of moles of solute. And number of delta dB, elevation of boiling point is directly proportional to number of particles of solute. Shall I write like this? Number of particles of solute. Now tell me later, which is the correct answer? Are you there? Bhuvaneshwari?
Sir, BaCl2.
How many particles get beta here?
2.
Here how many we get?
3.
Plus 2 moles of Cl minus. So how many moles we are getting here? 2 moles here, 1 mole. Total how many moles we are getting? 3 moles of ions I am getting here. 3 moles of ions. Here how many moles I am getting? 2 moles of ions I am getting. So elevation of boiling point depends upon number of moles of solute or number of particles of the solute. So definitely what happened? Barium chloride, if I add, more elevation of boiling point takes place. Correct or not?
So what if urea was there in the options?
Where if you take what urea, if I take what happened glucose, if I take what happened sucrose, right? If I take this one, how much? 0.1 concentration, 0.1 m, 0.1 m, 0.1 m. All are take what? Same concentration. Urea, glucose, urea is nothing but NH2, CONH2. Glucose is what? C6H12O6. Sucrose I have taken C12H22O11. Now, do they dissociate into ions beta? These are organic molecules. Even you take benzene also. Take some benzene solution also, you take anything. Do they dissociate these three? Never. They do not undergo any dissociation beta. If they don't undergo dissociation, how many particles will be there in the urea? 1. Glucose 1. Sucrose only 1 particle. And the concentration also same here. You have to see the concentration also. So we have same concentration. They are having same concentration. See, here I have taken same molality beta. Both are having same molality, but even though they are having same molality, same concentration they are having, but this is having high elevation of boiling point because they are having what? More number of particles. Here same concentration is there and same number of moles also there. So all will have same elevation of boiling point. So what we have to identify here, whether the solute particles present in the solution is dissociate or associates, that we have to consider. Here it will dissociate to give 2 ions. Here it will dissociate to give 3 ions. For example, if I take what sometimes acetic acid, I told you will undergo dimerization, correct or not? Will undergo dimerization and 2 molecules will get 1 molecule. Or 1 molecule will get half molecule. In that case, 2 particles are converting into 1 particle. If it is association takes place, if association takes place, in that case, 2 particles will convert into 1 particle. In that case, what happens? Elevation of boiling point will decreases. So this topic is in the want have factor we need to discuss, but want have factor is deleted from the portion. So I think this will not be comes in examination point because it is not there in the syllabus, right? But you may get in the NEET level. Now tell me better, which of the following causes more depression in freezing point beta? More depression in freezing point. Depression in freezing point is delta TF. Directly proportional to molality. Delta TF directly proportional to number of moles of solute and particles. And also what? Particles. Not only depression in freezing point, relative lowering of vapor pressure. That means what happened? Elevation of boiling point, depression, freezing point, osmotic pressure. Everything depends upon number of moles of solute, otherwise number of moles of particles of the solute. Now tell me beta, here how many ions are there beta?
2.
Here how many ions are there?
4.
4. Here how many ions are there? Samrin? Samrin, I'm asking. Samrin. Option number B. How many ions are there? Samrin, absent. Samruddhi, absent.
Yes, sir.
समृद्धि बोलो बेटा कितना आंसर है यहाँ पर?
2.
2 ions. Now here, anybody?
2.
2 are there? No beta, 4K plus 4K plus efficient taken 6 times got in coordination compound or not? How much it will be? -4. So there are 4 cations are there and 1 anion is there. Total what happened? 5 ions are there. So definitely the answer will be what here? D will be the answer here, right? This one will be the answer. Total how many particles are there? 5 particles are there. 4 plus 1 is equal to how much here? 5 particles are there. A will produce 2, B will produce 2, C will produce 4 particles only. Right? Now let me discuss about the problems on osmotic pressure beta. We'll see the problems on osmotic pressure now here. Now 200 cc means how much beta? 200 cc means how much? 200 ml beta. 200 ml, right? Of volume of the solution is given. Volume of the solution is given. See, this one is what? Volume of the solution. Next, V volume of the solution. Next, weight of the solute is given. I told you, no, we can calculate the molar mass of the protein. The one of the application of the osmotic pressure is what, beta? Calculating the molar mass of, molecular mass of what? Protein. So osmotic pressure is how much given? This much, 2.57. And weight of the protein is given to 1.26 grams. Everyone I'm writing. Osmotic pressure, I got here. Next, volume 200 ml, but 200 ml is equal to what? 0.2 liter. Why I have to take 0.2 liter? I will explain. Okay, later let me see. Next, temperature, how much they given? 300 Kelvin. Here it is given. 300 Kelvin. Right. And weight not written here. Weight also written. Weight also got. Weight how much? 1.26 grams. Yes, 1.26 grams. And R you take what happened? Now, why you have to take this volume in liters, like 0.2 liter? Why I have taken? In that case, it depends on the R value. You observe R value is what? 0.082 if I take in atmosphere liter, if I take atmosphere liter, will take 0.083 if you take in bar liter here. If here you see osmotic pressure is in terms of given bar, the pi is given in terms of bar, then definitely R also must be in bar. If pi is given in terms of atmosphere, ATM, for example, pi is given something 2.57 into 10 to the power minus 3 atmosphere, ATM is given. In that case, this will be the R value. For example, if they given what happened, 2.57 10 to the power minus 3 bar, if they given, you take 0.083. Now, how their R value, how it is L, R or S, whatever it means. Generally, they will give R only. Okay. For our explanation, I have taken S, but generally R only we take actually, right? S and R both are what same. Nothing is different is there actually. Now, bar liters. So if R is in terms of liter, generally R will be in terms of liter only. Therefore, the value must be always taken in terms of liter only. Don't forget this one. Here only most of the students are getting mistakes here. They are directly applying 200 there. They are getting wrong result there. Understood better? Always take the volume of the solution in terms of liter, because the R value is also in terms of liter. Correct or not, beta? This one. Now, what is the formula, beta? Formula is what? Pi V is equal to nRT. Pi V is equal to nRT. This is the formula. Correct or not? Now, pi V is N is equal to what, beta? Weight of protein. Weight, I'm taking what? 2 for solute, beta. 2 means what? Solute. 2 is nothing but protein actually. Solute. W2 by M2. Molar mass of the protein into RT. Into RT. Now, we are calculating what actually? Molar mass of the protein. M2 we are calculating. Now, M2 is equal to what we can write? M2 is equal to W2 RT divided by pi. Now, substitute W2 is equal to how much, beta? 1.26 grams. Right? Next, what happened? R value is what? 0.83. Temperature is what here? 300 divided by. Osmotic pressure is how much given? Osmotic pressure is given what? 2.57. This one. 2.57 10 to the power of minus 3. And volume is given how much, beta? 0.2 liter. Now substitute everything. You are getting 610 grams per mole, which is a gram molecular weight. It is. Molar mass is what? 610. Very simple problem. Two things you have to remember. R value, liter, volume also liter. Next thing is that formula. Right? Any doubts regarding this one you are having? No doubts? Now let me take this last question. We'll discuss only last question. After that, what happened? We'll finish this one. An aqueous solution 1 liter. Volume is given. Containing 6 grams of urea. So osmotic pressure is found equal to solution of glucose. How much weight of glucose is present in the 1 liter of solution? What they are saying, this is isotonic solution, because osmotic pressure is same for two solutions. If osmotic pressure is found equal, then the solutions are in isotonic. Pi 1 will always equal to pi 2. Correct or not? So I am writing here like osmotic pressure of urea is equal to osmotic pressure of glucose. Correct or not? Based upon the problem given data, I am writing like this. Now, what is pi? Pi is equal to what beta? CRT. CRT. So concentration of what I am writing, concentration of, isn't it? Urea into RT is equal to concentration of glucose into RT. Will be same or different beta? Tell me beta. Same or different this one? These two values will be same or different?
Same. Same.
Now, R value get cancelled. Temperature also same. Anyway, they mentioned here, definitely temperature will be same also. If you don't mention also what happened, then they will mention that one, no problem. Temperature definitely will be same, in that no problem. Now, concentration of urea now is equal to concentration of glucose. Correct or not? Whenever, remember beta, whenever two solutions are in isotonic, their concentration will be same. In the previous case, I told you blood is what? Isotonic with what? 0.9% of salt solution. Then these both are having same concentration. So I can write directly like this. Whenever osmotic pressure is same, you can write their concentrations also same. Correct or not? When whenever osmotic pressure is same, the concentrations also will be same. Now what I can write based upon concentration? Number of moles of urea divided by volume of the urea. Similarly, number of moles of the glucose divided by volume of the urea. Now, again I am writing over here. An aqueous solution of 1 liter containing 6 grams of urea, its osmotic pressure is found equal to the solution of glucose molecular weight. Now here, both our volume also will be same now. Both volume also will be same. Now remaining will be what here? Number of moles of urea. What is that number of moles of urea? Weight of urea, molecular weight of urea. Now is equal to weight of glucose divided by molecular weight of the glucose. Now weight of the urea, how much given beta? 6 grams. Put here 6 here. Molecular weight of urea, how much is given? 60. Put here 60. Weight of glucose, you have to calculate. Molecular weight of glucose, how much beta? 180. Now what we get here? Weight of glucose is equal to what? 6 into 180 divided by 60. 6 cancel. 6 is cancel. How much will be answer? 18 grams will be the weight of the glucose. With this we can easily calculate weight of the glucose. How much we get beta? Everything we get 18 grams. This is the answer. Very simple problems these are. Whenever if they given isotonic solutions, C1 will be C2, V1 will be V2. When you get pi 1 equal to pi 2, this will be like this. When you take pi 1 equal to pi 2, C1 equal to C2, V1 equal to V2. Even T1, T2 also will be equal actually because it is at same temperature. So with this what happened, I have completed osmotic. Now do you have any doubts?